Hello friends, welcome to Shiksharthi. In this video, we shall be learning and unlearning a few concepts and misconceptions with a fresh perspective on it. So the agenda for today is, we'll be doing fractions along with numbers, and to be more specific here, we'll be doing fractions along with divisibility rules. When I say divisibility, I'm talking about remainder theorem. So, we all know that proper fractions is a variety of a fraction. Similarly, improper fraction is another variety of a fraction. And the third variety of a fraction, which I have already talked about earlier, is an ideal fraction. Right? Incidentally, I have not mentioned it here because the objective is different here. So now, we all are aware of the fact that divisibility, when I talk about divisibility, we basically talk about what? We talk about dividend is equal to divisor into quotient plus the remainder. Now when I say this, I'm assuming capital D as dividend, small d as divisor, small q as quotient and small r as remainder. Right? So let us say if somebody gives me a question like divide 13 by 4, this is how I'm going to write. If I have to write down the same expression in terms of a fraction. Now this 13 is my dividend and 4 is my divisor. So here now the dividend becomes what? The numerator in terms of a fraction, and the divisor becomes the denominator. I hope this part is okay. Okay, going forward, now when I do this, how will I do this? How will I do this division? So 13, I can write it like this is 4 into 3 plus 1. Keeping in mind that this is my dividend, this is my divisor, this is the quotient, and this is the remainder. So as discussed earlier, capital D is for dividend, small d is for divisor, small q is for quotient, and small r is for remainder. And we will consider all of them to be non-negative. Now all of these are non-negative for the time being. Now when I say non-negative, what do I essentially mean? I mean that they are either 0 or greater than 0. Right? Okay. So taking this forward, now when I divide this, I got the quotient as 3 and the remainder as 1. So please relate. When I divide the numerator by a denominator, I can write it as what? This can be written as, this 13 by 4 can be written as 12 plus 1 divided by 4, which can be further written as 3. Now 4 3 is 12. So now after this I can write it like this. Yes? Okay. So in that case, we get a synergy between the two topics. So one is number system, let's say divisibility rules, and the other topic here is again fractions, which is a part of numbers only in a certain way, but we are trying to take them as different topics as of now. So can I write that a numerator upon the denominator can be written as quotient, right? R upon D. R divided by D, where small r is the remainder, small d is the divisor, and small q is the quotient. And we call this format of a fraction as a mixed fraction. Right? So when I write a fraction as, if a fraction n upon d is written as q times r by d, the thing to be understood here is this is q plus r by d. This is which format? This is the mixed fraction format of a fraction. Okay? So I'll request you to focus your attention on these two things. Just go through these 4 examples that I have written, and I'll speak to you in the next 2 to 3 seconds. Okay. Now let me start off with a positive proper fraction. We know that proper fractions also can be subdivided. Now this subdivision would be 2 subdivisions. The first one would be when I talk about a negative proper fraction, which can be written in the inequality form like this. And the other format is again the inequality format, or I take a tangible example of the same. And the example is plus 11 by 21. Now whenever I take a proper fraction, so let us say the proper fraction that I have taken here is n upon d. So whenever I take a proper fraction, the remainder is always the numerator itself. I'll repeat, in a proper fraction, the remainder is always the numerator, but we know that the remainders can never be negative. So, in between, let me take this discussion to the next level. And for this, you need to come this side. So here what I am doing is, I am taking the divisor as 4, the same example that I had taken. So when I take the divisor as 4, I can write down dividend is equal to 4q plus r. At the same time, I can write it down as 4q dash minus r dash. Now what do I intend to convey? Now here, I have already taken this example. This could have also been written as 4 into 4 minus 1. Now when I am taking r dash here I am assuming it as a negative remainder. So coming back here now, r is the positive remainder here and r dash I am assuming it as a negative remainder. So if I take a number and if I am dividing it by 4, how many remainder possibilities will I get? In total I will get 4 remainder possibilities, and those 4 remainder possibilities are either I get 0, which is saying totally divisible, and these are when they are not totally divisible. I'll repeat, the tick mark that I have taken is when I am taking a dividend and I am dividing it by a divisor and it is totally divisible. So tick mark symbolizes what? Symbolizes that the remainder is 0. Now cross symbolizes that I am getting a non-zero remainder. So if I am dividing a number by 4 and if I am looking for a non-zero remainder, the non-zero remainder, how many possibilities will I get? I'll get 3 possibilities, and those 3 possibilities are 1, 2 and 3. Now the best way to understand the negative remainder concept here is, which is a pseudo concept. It doesn't exist in reality. I'm just trying to make it exist. Okay. So how much should I add to a 1 to get the divisor as 4? I should add a 3, but how can I add? This is just a pseudo concept. So you put a minus sign there. Similarly, if I am dividing a number by 4 and I am getting a positive remainder as plus 2, in that case the negative remainder would be what? Minus 2. If I am dividing a number by 4, if the positive remainder is 3, how much would be the negative remainder? It's just like saying how much should I add to a 3 to get a 4? The answer is 1, but put minus along with 1. Hope you understood. So coming back, using the same logic now, if I take a negative proper fraction and I know that the remainders are never negative, I'm talking about the real remainders. So in this case, I can write down this fraction like this, or I can write it like this. In short, I get a negative remainder. Few minutes back only we talked about when we divide a proper fraction, the remainder is the numerator itself. So from here itself, I could have said that the remainder is what? Minus 11. But at the same time, we know that the remainder cannot be negative. So add the divisor to it to get the positive remainder. In short, you can take this as a formula, as a basic concept. In order to get the positive remainder, you need to add what? The negative remainder along with the divisor. That's correct. And in order to get the divisor itself, I can say what? Subtract the negative remainder from the positive remainder. So if I do 1 minus or minus 3, what do I get? 1 plus 3, which is 4. This is what I am talking about. So how much is the remainder in this case? The remainder is plus 10. How much is the remainder in this case? The remainder itself is positive and the numerator is supposed to be the remainder. Plus 11. Now in this case, I can write down this fraction either like this or like this. In this case, the remainder is plus 1. In this case, the remainder is minus 10. But the moment I add minus 10 to 11 in order to get the positive remainder, the remainder had to be what? Plus 1 only. Last but not the least, here how much is the remainder? Can I say plus 10? Of course. So the more you practice, the better you'll understand. If you feel that something knowledgeable was discussed today and which helps you when you're doing various questions at various places, do not forget to like, share and subscribe to our channel. If you have already done so, please turn on the bell icon so that you start receiving further updates. Thank you so much. Until next time we meet, goodbye.